Welcome back, Logan, to another installment of Math at Your Couch. Today we're going to carry on where we left off yesterday's video, talking about solving square root equations. Except today what we want to do is we want to look at two things primarily. The first one is how do you deal with a problem where there are multiple square roots in it? So how do you deal with an equation that has multiple square roots? And then the second thing I'd like to discuss is what happens, what are these things that we call extraneous solutions? So what are those things? All right, so we're going to talk about the first thing I'd like to talk about is extraneous solutions. And extraneous solutions are the byproducts of squaring both sides of an equation, and they're the solutions that actually don't work. So one more time. If you square two sides of an equation, there is a chance that your solutions, some of them, may not work. And the ones that don't work are what we call extraneous solutions. So they're the byproduct of squaring a equation and the result solutions that don't work. All right, so let's take a look at a couple of examples. Our first example is going to deal with multiple square roots. So what happens when you have multiple square roots in a problem? Kind of like example number one. Well, it's not that bad. All you want to do is you want to separate your square roots onto both sides of the equation. So we separate the two square roots so that one's on the left side and one's on the right side. And we deal with it now just like we would any equation with square roots. We would use the square to eliminate them. So on the left side of the problem, I have a square root of 2x plus 6. Now to get rid of that square root, I'm going to want to square it. So what I'm going to do is I'm going to rewrite the entire equation. So we got x plus 11. And then on the left side, I am going to square it because I want to cancel out the square root. But if I square this left side, I must also square the right side. And in squaring the left side, the square and the square root will cancel, leaving us 2x plus 6 is equal to, and now I need to square the right side. And when I square the right side, notice there's a square root to cancel my square, which results in just x plus 11. So not a whole lot of actual calculations, but more math of canceling. And now we solve it by subtracting x from both sides. We now have a linear equation, and this gives us x plus 6 is equal to 11. We subtract 6 from both sides, and this gives us x is equal to 5. And this right here is our solution, but we need to check to see if it's an extraneous solution. So you'll notice that we squared both sides of the problem. Now, in the last video, we didn't talk about this because I just wanted you guys to get through the technique of how to solve these types of problems. But you'll notice that when you square them, there is a chance that your solutions actually don't work. So what we're going to do is we're going to check to see if the solution works. So we're going to take that x right here, and we're going to turn it into our solution, 5. So I'm just going to plug in a 5 right there. And we're going to take our x over here, and I'm going to change that into, that's right, a 5, because that's what x is. So now we're going to check to see if this works. Now, 2 times 5 is 10. So we have the square root of 10 plus 6 is equal to the square root of 5 plus 11. Now 10 plus 6 is 16, so we get the square root of 16. And 5 plus 11 is also 16. And at this stage, you're like, they're exactly the same. They are identical to each other. And this gives us 4 is equal to 4. And this means that x equals 5 is actually a solution. Not an extraneous solution, but a solution to the problem. All right, let's try this with another example. Example number 2. So our second example, we have 7 is equal to 23 plus 2 square root of x. A little bit different because there's not two radicals or two square roots in this problem. So we just want to approach the problem by solving it the way we solved in the last video. Isolate the square root. So we're going to subtract the 23 from both sides of the equation. Subtract the 23 from the left and subtract it from the right. The result is negative 16 is equal to 2 square root of x. Now from here, you're going to want to isolate the square root by dividing by 2. So we're going to get the square root of x by itself on the right side by dividing by 2. Divide 2 to both sides to balance it, and we get negative 8 is equal to the square root of x. All right, so from here, we're going to square both sides of the equation to get rid of that square. Now that the square root has been isolated, this gives us negative 8 is equal to the square root of x, but we're going to square root the right side to cancel the square root, which means we have to square the left side to balance it all out. This gives us negative 8 times negative 8, which is 64, which means x is equal to 64. Now, since we squared right there, since we squared both sides of the problem, the chance of an extraneous solution has arisen. So what we're going to want to do is we're going to want to check to see if this solution, 64, actually works. So we're going to take that x right there, and we're going to change it into a 64. So now we have 7 is equal, I'll write it over here, 7 is equal to 23 plus 2 times, instead of saying square root of 64, let's just say what that is. That's just 8 right there. And then we get 7 is equal to 23 plus 8 times 2 is 16. And now we're going to add the 23 and the 16, which comes out to 39. Now, 7 is equal to 39 is a false statement, which means 8 is actually, which means 64. What we tried to plug in is actually not a solution. So what we're going to do is we're going to cancel this guy out right here, and we're going to say, well, there are no solutions. So our answer is that this problem has no solutions, because our only solution was extraneous, which means this problem has 0 solutions. There are no answers to this problem. All right, moving on to our third and final example. What we have here is x equals the square root of x plus 20. Once again, you only have one square root on this problem, so there's no reason to separate them. The square root is isolated, so all we're going to do from here is we're going to get rid of the radical. So the square root, So we have x equals the square root of x plus 20, but we want to get rid of the square root on the right side. So we're going to take the entire right side and we're going to square it. Now, since we squared the right side, we're going to have to balance it by squaring the left side so that it stays equal. The result is going to be x to the power of 2 equals, and over here it's going to cancel out, leaving us with x plus 20. Now, once I have an x squared, this right here is not a linear equation, but a quadratic, so I want to get everything to one side. I'm going to subtract the x from both sides. Nowhere to subtract it, so I'm just going to throw it up there. Subtract the 20 from both sides. Nowhere to subtract it, so I'm just going to throw it up there. And on the right side, you'll notice that I now have 0. I have equals 0. I'm going to rewrite the x squared, the x, and the 20 in descending order from the largest exponent to the smallest exponent. So I have x squared minus x minus 20 equals 0. Now, solving it from here, you have 4 options. You can either graph it, not a really good idea. You can use the quadratic formula, always works, just takes some time. You can complete the square. That's a lot more math involved for this problem, or you can factor it. The best technique, however, it requires you to think for a second or two to figure out whether or not the factors of the front and the back can actually result as a sum or a difference of the middle. So on this one here, I'm going to actually factor it. So just review factoring. We're going to say we need 2 binomials that multiply to give us this trinomial. Now, to multiply to get x squared, we're going to need an x times an x. That'll result in an x squared. And now we need to think of 20. There are 3 things I can think of. You can either multiply 1 and 20. The problem with 1 and 20 is that when you add those 2 numbers, you get 21. And when you subtract them, you get 19. Neither of them is negative 1. My second one is 2 times 10. 2 and 10 can give us 20. But when I add 2 and 10, I get 12, not the middle. And when I subtract 2 and 10, I get 8. Once again, not the middle. My last possibility is 4 and 5. 4 times 5 is 20. And now when I add 4 and 5, I get 9, not negative 1. But when I subtract 4 and 5, I get 1, which is a version of negative 1. I just need to figure out how to make it negative. So I'm going to use the factors of 4 and 5. Now, to get a negative 1, it would have to be a negative 5 and a positive 4, like that. And that's the factored form of it. Like I said, it's a lot faster than using the quadratic formula, but it does require you to do a little bit more thinking. And then you can get the answer very quickly, as long as it's factorable. All right, so now we have 2 binomials equaling to 0, which means both of them must be equal to 0 by themselves using the 0 product property. Subtracting 4 from this little equation gives us x equals negative 4. And adding 5 to this little equation gives us x equals 5. Now, because we squared both sides of the problem right there and right there, the chance of extraneous solutions has arisen. So what we want to do is we want to double check our solutions to make sure they work. So I'm going to take this equation here and then change all the x's to 4, negative 4, sorry. So we have negative 4 is equal to the square root. And instead of x, negative 4. But there's no more x's, so I'm just going to write down plus 20, and we simplify. So we have negative 4 is equal. Negative 4 plus 20 comes out to 16, and square root of 16 comes out to 4. This does not make sense. Negative 4 does not equal 4, which means the number I plugged in that gave me that result does not work. So this is not one of our solutions. It's an extraneous solution. I'm going to test 5. So I'm going to do the same thing for 5. So we're going to say 5 is equal to the square root. 5 was x. This x is now going to turn into 5. And the 20 is going to say plus 20. So now we have 5 is equal to the square root of 25. And the square root of 25 is just 5. So we have 5 is equal to 5, which makes perfect sense. So we're going to say that our solution right here actually works. It's not extraneous. It is our solution. Our answer to question number 3 is x equals 5. All right, if you have any questions, go ahead and hit me up on Google Classroom or send me an email, and I'll be sure to get back to you as soon as possible. Otherwise, I'll see you guys next week. Hope you have a great weekend. Talk to you.